large enough, it can cause electrons to move through air and insulate. We also know what can happen when a wire is connected between two charges. What? In these examples, the reactions occur due to a tremendous number of electrons moving from one charge to another. This movement of electrons is called current flow. In this lesson, we'll show you a few things about current. But before we get into the subject, let's review a few facts that we've already talked about. For example, in the discussion of voltage, we showed some methods of creating negative and positive charges. The car battery was an example of creating a voltage by chemical means. Remember, the electrolyte of the battery reacts with two metals, causing one to gain electrons, the other to lose electrons, or one becomes a negative charge, the other a positive charge. Now, if I connect the bulb across the charges, like this, the bulb will light. We've used the voltage of the battery to do some work. But what causes the bulb to light? Well, remember, this material contains an excess of electrons. This one a deficiency. If a suitable path is provided, electrons will leave the negative charge, travel to the positive charge, and try to neutralize it. So it's the movement of electrons caused by the voltage that lights the bulb. The pressure causes current flow. But how do we know that electrons are moving between the two charges? Well, under the right circumstances, we can see it. We said that this device develops a tremendous voltage, so much that it will cause electrons to travel through air. Now, electrons are solid particles, so if they're moving between these rods, we should be able to detect them. To detect them, I'll use this paper. I'll pass it between the rod and the arc. Now, if we have solid particles moving between the rods, they should penetrate the paper. Let me turn it on, and we'll see what happens. Get the arc going real good. And I'll pass the paper through the arc. Do it several times. I'm moving the paper very fast because if I don't, the arc will burn it up. Okay, that should be enough. In the case just a moment ago, then, our bulb glows due to a movement of electrons. Due to a movement of electrons through the filaments of the bulb. Now remember, this movement of electrons is called current. And current does the work in electricity and also in electronics. Now since current does the work, it's important that we know the conditions required to happen. Now remember, when I speak of current flowing from negative to positive, I'm referring to the current that flows outside the power source, or the current in the external circuit. Inside the power source, the battery in this case, current flows from positive to negative. Now this is a very important point, so be sure that you understand it, because later on you'll be using the current in this power source to calculate numerous things. So remember this. Current flows in a continuous path from negative to positive in the external circuit, and from positive to negative in the power source. Now, you should also remember that the requirements for current are a source of voltage and a continuous path through which current can flow. Here are some terms associated with current that you should become familiar with. For example, the symbol for current is the capital letter I. A coulomb. That's a measure of the amount of current. Now, 1 coulomb is this many electrons. Now, of course, trying to count this many electrons would be like trying to count the grains of sand on the beach. It just isn't practical. So we'll rely on meters later on to measure current in amperes. Now, an ampere is 1 coulomb flowing past a point for 1 second. And it's called ampere in honor of the French physicist who discovered this means of measuring current.